All right, we are ready to move on to the last question from section 7.3. So this is 7.3, number 7. Again, I'm going to have to worry a little bit about domain this time, so I'll just warn you that right off. I'm going to be playing around with that domain. For number 7, it says, if cosecant of x equals 9 for all degrees of x between 90 degrees and 180 degrees, then sine of x over 2 must equal what? Well, in your direction, it's also going to say without solving for x. So we are not trying to solve for x here. All we are trying to do is use the information given, and we've done this before. It's the same kind of problems that we started off this semester with. So if we know that the cosecant x equals 9, well, cosecant is 1 over sine x. So 1 over sine x equals 9. Well, I want to know what sine x is, so I can take the reciprocal of both sides, and I would get sine x equals 1/9. Alright, now remember our handy dandy little reference triangle that we can use with, let's say, this angle being x. This side length is going to be 1, and our hypotenuse is going to be 9, because we know that sine is the opposite over the hypotenuse. And so now let's figure out what this side length a is equal to. Well, we could say a squared plus 1 squared equals 9 squared, or let's just say 81. And I want to solve for a. So we're going to subtract 1 from both sides. We'll get 80. And then we'll take the square root of both sides. We'll have a equals the square root of 80. And then let's go ahead and simplify that. 80 is equal to 16 times 5. And then that would simplify to 4 square root of 5. Now, what we also have to remember is that we have a certain domain that we need to hold to. This domain that they're giving us is in the domain from 90 degrees to 180 degrees. That is all of quadrant 2. So that's telling me that all of my solutions are going to have to be in quadrant 2. Therefore, my cosine values are going to have to be negative, and my sine values are going to be positive. So remember, we have negative, positive solutions in quadrant 2. All right? Now, this is when I'm only talking about this upper part, okay? Because this is the cosecant of x, which then turned into the sine of x once we rewrote it and solved for sine of x. But notice when we get over to these questions, then we're going to be working with sine of x over 2. So the sine of x over 2, we're going to have to work with our domain again and change it a little bit. So just keep that in mind. We're working with two totally separate things right here. All right, on this side over here, now we know what the sine of x is. Let me just underline that so that we will be able to find it easily enough. And then we also are going to need cosine of x to do these problems. Cosine of x is going to be in this triangle. Let's fill in our a, 4 square root of 5. It is the adjacent over the hypotenuse. So cosine of x is going to be equal to 4 square root of 5 over 9. All right, now this is all just scratch work to get us going and give us all of the information, most of the information that we need to know for these equations over here. So now let's go ahead and get started over for the problems that we want to find. So first thing that we need to talk about is our domain. We want sine of x over 2 for all values of x between 90 and 180 degrees. Problem is, now we have gone from angle x to angle x over 2. We're looking at the half angle identity. So let's work with this domain and change that domain so that we know what it is for x over 2. So if we had 90 is less than x is less than 180, well, what do we want? We want it to be x over 2 To get x over 2, I would have to divide x by 2. If I divide that x by 2 in the middle, I have to also divide everything else in that inequality by 2. So now I have x is between 45 and 90. So now what happened? We just changed quadrants. Now we want our x value to be between 45 and 90 degrees. So now what do we know? If it's a half angle identity that we're looking at, our cosine values are going to be positive. In quadrant 1, we have positive and positive sine values as well. So we'll remember that as we find these answers. All right, so now sine of x over 2. Let's go ahead and take a look at our trig identity sheet. So sine of x over 2, and here theta is going to equal x when we're doing that identity. So we have plus or minus the square root of 1 minus cosine of x over 2. All right, I don't want you to get too confused with what we're looking at here. This cosine of x inside here, this is not a half angle. It is not x over 2. So I am not taking my domain from this information over here. I am taking my domain from this information here. So when I have cosine of x, have we found cosine of x? We did actually find that, right? Cosine of x is equal to 4 square root of 5 over 9. So we can rewrite our square root. I'm going to rewrite it as 1/2 minus 1/2. We would do cosine x, but, oh, what did we say cosine has to be over here? Sorry. Because of our domain over here, cosine has to be negative. We talked about that, but when I put in my final answer, I didn't make it negative. So because of our domain, we want this to be in quadrant 2 for all x values. Then we have to have a negative for our cosine. So our cosine of x, when we plug it in here, is going to be negative 4 square root of 5 over 9. Right? And then when we were working with the half angle identity, this is equal to x over 2. So for the sine of x over 2, since this is what we're finding, we need to use the domain for x over 2, which is in quadrant 1, which is going to tell us that our sine value is going to be positive. So this is going to equal positive square root of 1/2 plus, because I got a negative and a negative there, 1/2 plus my 4 and my 2 are going to cancel, and I'll be left with 2 root 5 over 9. And that is our answer for part A. Okay, now coming down to the cosine of x over 2. Let's go right to our half angle identity. It's going to be plus or minus 1 plus cosine of x over 2. Now we're still using all of the same exact information. It's still just a separate part of number 7. So our cosine x is still equal to what we had over here, the negative 4 square root of 5 over 9. And I'm going to rewrite those as fractions. So I have plus or minus the square root of 1/2 plus 1/2 times cosine x, which our cosine x is here, the negative 4 square root of 5 over 9. And then let's just make that look a little bit better. And did we want the positive or the negative for this one? This cosine, this is for our half angle identity, so we're pulling from this domain over here, our x over 2. Once we take that domain and solve for x, we need it to be in domain quadrant 1. So cosine is going to be positive also. So we're going to have a positive square root 1/2 minus, this time, because we've got a plus and a minus, minus 2 and our 4 will cancel. We'll be left with 2, so minus 2 root 5 over 9. Okay, the very last one doesn't quite fit on my page, but it is the tangent of x over 2. Now normally on these trig identities formulas sheet, it will have tangent in there also, another formula for tangent, but you don't really need to memorize, and we don't ask you to memorize another tangent one, because we already know what cosine is and we already know what sine is. So tangent of x over 2 is going to equal sine of x over 2 over cosine of x over 2. Then we already found sine. That was the positive square root of 1/2. Oh, go away. 1/2 plus 1/2. No, let's put our more simplified version in there. 1/2 plus 2 square root of 5 over 9. All over what we get for cosine, which is the square root of 1/2 minus 2 root 5 over 9. All right, now MyOpenMath will actually accept this answer right here, so you can just leave it like that. The nice thing is you can go up to part A, you can highlight all of that, copy it, paste it down to your tangent answer, do a big division bar underneath all of it, copy cosine, and paste it below your division bar. It makes your tangent one really nice to do. And that is all I've got for you guys. So that finishes up section 7.3. You should be able to get through all of numbers 1.1 through 7. But if you have any questions or any problems, just let me know. You can give me a call, text me, email me, whatever it takes, I'll be there.